I think I prefer to just do a short discussion on something that I didn't manage to cover yesterday, and then we take it next week, okay, the discussion on the exercise set. Because it will take some time, and I think it's already a bit tight. Yep. Here we were missing some. I forgot. I don't know your name. Sorry, but let me just get it here. Okay, we have Peter. Who else was on that group? Anders. What before? Yun. Okay, and yes.
Yeah.
Okay, good.
One more thing.
Yep.
Oh, yeah, it's Arman. A-R-M-A-N.
Arman. Okay, Arman. Okay. So we were discussing last class that we make like an accountancy at budgeting table, and that's what you will have to make for exercise. You can do it without this table, right? You can simply use the equation we showed yesterday. NPV simply is the sum for every year, time equal 1 to n. That's the number of years of the cash flow of time t divided by 1 plus I to the power of t. Okay, where I is this discount rate, and that depends from company to company, but actually compares how it should be better than just putting the money in the bank, okay, and putting the money on the bond. It should be better than that. And typically values as low as 5, maybe as high as 15, they are used. But it's typically some number at 8, 7%. Okay, so, and you can also compute that. Sometimes they call it, you can actually split. Okay, you can actually have that this is the sum from T1 to N of the revenue, okay, minus the sum at year T minus the sum of the expenses. Okay, and some people like to work separately on those, but you know, it should give you the same result. But we have here, we said, I think we have to make it more to the left. So we had here CAPEX, DRILLEX, OPEX, and then we had here revenue, sales revenue. Then we have our cash flow. Okay. And I told you that cash flow, if we plot it with time, the cash flow is going to be simply, you don't have a continuous function. Okay, you have a discrete function for every time, 1, 2, and 3, 4, etc. Cash flow in Norwegian NOK. Okay, initially you're going to have big investments, and then at some point you have more revenue. It's going to look something like that. Okay. We said we use sometimes the cumulative cash flow, where we actually are summing up for every time. We're summing up all the cash flow from the previous years. Okay, and I think we have done a figure on that yesterday. Okay, like you will see, let's try to make this cumulative, not probably won't be 100% correct, okay, but you see that initially you have the cumulative, you have a lot of expenses, and then gradually it will start to go up, and then it will stabilize. Okay, that's the cumulative cash flow. Okay, but remember, I'm summing. Here I have the limitation. I'm summing money that happens in different times. Okay, revenue that happens in this year with revenue that happens in that year. And we know the value won't be the same. But typically we use this chart to point the what we were discussing also earlier here, the time of highest financial exposure. Yep. And we have here when the point starts to be all the cumulative. Remember, we are summing all of them. So for every time you have to take into account the equation we said was this one was simply that one, but this one will be this one plus this one, and so forth. And this is the break-even time. So it's exactly how long does it take to recover your investment. But really we use the discounted cash flow to make the sum of all of them. And at the end, if we can have two things. We can make, if we sum all of them, will be the NPV, net present value. Okay, this discounted cash flow is simply the cash flow divided by 1 plus I to the power of t, the number of years. Or I can also have the NPV or the cumulative cash flow, discounted cash flow. How the NPV is changing per year. Okay. So this big number, NPV, is what I use to decide. It's basically the main number I assign to the project to decide on how profitable it is. Okay? Very high NPV, very big NPV usually means a very robust project. Very low NPV, close to zero negative, stay away from that project. It's very simplistic, but actually that's the main indicator that is used. Okay, I also have, there are some other indicators like internal rate of return. So is the value of the discount rate that gives NPV equals 0. Okay, and usually the higher the number, if we make a plot, and this part is very well explained in the reference material, the book of this petroleum production and exploration. You see that the interest rate initially you can make a plot with NPV. Initially it's very positive. Let's say here we have 7%, and then we start increasing it until it becomes 0. Okay, and that will be my internal rate of return. So usually if it's very big and very different, very much higher than the 7 or 8%, that means it's a very robust project. And sometimes we use that indicator. And the other indicator we use is the break-even hydrocarbon price. Okay? And that means the oil price or gas price that makes the NPV equal to 0. Okay, until which value the project still will be profitable. Okay, and just now a short comment on we cannot simply accept to compare different options. We cannot simply accept one number. Okay, we have to start to evaluate the effect of uncertainties. It is always important to evaluate the effect of uncertainties on NPV. Okay, like we have before, right? We have our block that we have our NPV calculations, our budgeting calculations, capital calculations. So then we calculate this magic number NPV IRR, or this break-even price, and we have here some input we have used for that, right? We have, for example, the oil price of oil. We have the capex. We have drill legs. We have also even the size of the reservoir. That's something we are not sure. The total recoverable reserves. Actually, this affects the production profile, right? And the production profile affects that. Okay, and you want to see how that affects that number. So we are going to talk, that's not the best way, that's how it should be done, but that's how the industry is doing it. Okay, so they use the principle called ceteris paribus. Okay, that means in Latin, one at a time. That means you perform, roughly said, is to perform sensitivity analysis by changing one variable at a time. Okay, so that means oil price you change 20% higher, 20% lower, and record these three cases. Okay, so you have NPV and you have oil price and you have the base case. Let's put this one below. And you say, well, that's a bit simplistic, but really that's in many cases the industry is simply using this. Okay, use a lot of very complicated technical decision how to decide on the number of wells, but then to see the robustness of the project, they just evaluate a few cases. Okay, so oil price, for example, you try 40 is your base case, but then you try 60 and then you try 20, and then you compute the NPV for each one of these cases. Then you make another table where you make it for capex. Okay, capex typically during the development phase has an uncertainty of plus minus 20%. Okay, so they also change, keeping the oil price fixed equal to the base case. Okay, keeping the oil price at 40. Change capex plus and minus 20%. Okay, perform by changing one variable at a time, keeping all others constant. Okay, and the results are presented in typically there are two main plots that we use. One of them is called a tornado chart. Okay, and the tornado chart, basically you have on the y-axis, on the x-axis you have the NPV, right? And you simply locate your base case NPV. That you use 60, you use the regular value of capex, you use all the base case values. Okay, and that might be, I don't know, 4 billion NOK. Okay, and to avoid the issue SI, we say 4e to the 9 NOK. Okay, luckily we are engineers, so we don't have to, we can say it very clearly. Okay, then you come, for example, with the oil price, and then you make computation by increasing the oil price. Here it was 40, let's say $40 per barrel. Okay, and then you make it, for example, with 60. You of course are going to obtain a higher value of NPV, and then you make it again with maybe 20 or maybe 30. Okay, and you manage to plot these 3 points, keeping all the other things constant. Okay, and you make a bar like that, just showing the spread that you will have due to the oil price. Okay, and then you make one for capex. That's your base case capex. But if you use higher capex, the NPV should go up or down. down, right? If I have more expenditures, the NPV will become smaller. So here I have CapEx plus 20%, probably will have an NPV here, and then CapEx minus 20%, that will increase my NPV. Okay, and I can make this plot with any variable I want to analyze. Some things I want to see also is the delay in production. If my production is delayed for some reason, this shipyard in Norway or this shipyard someplace didn't deliver the ship on time, my production will be delayed by 2 years. How that's going to affect my okay? So that's delay, and here I have to increase the NPV has to be early production -1 year, and here I have my +1 year. Okay, and I have here a figure that's from the PDO of Goliath, okay, where you see exactly that you have the ±20% in investment. They include their compound RELEX, CapEx, whatever, and you see the spread. You see on the production, that means maybe the plateau rate, that means maybe the reserves in place, or you have also the oil price. Usually the oil price is the one, or the gas price, they have the most impact. So you have to make, for the second exercise, you will have to make a plot like that, and you have to find out how to make it in Excel, okay, as part of the fun. Another type of chart which is also used is what is called spider plot. Have you heard about spider plot before? No? Spider plot, basically I put the variable that I want to change on the y-axis, NPV, and then I put here on the x-axis, I put the variation of the percentage of variation of the variable, okay, of the variable. Okay. For example, let's say oil price. If there is no variation, I'm going to get some NPV on the oil price. If I have a bigger 20% variation high, I'm going to get a higher NPV. Okay. And if I'm going to get less, -20%, then I get a low. For CapEx, if I get plus 20% CapEx, I'm going to get probably a value here, NPV down here. And then if I get -20% CapEx, I'm going to get here. Okay, so that's for oil price. And that's for CapEx, okay, or expenditures. And I can plot any variable there. The nice thing there is I have the same axis, x-axis, for all variables. Here is like I have to have the variation, I have to have these two numbers to see how they are changing. Here I can say, well, if I change this 20%, how does it affect? And typically, if I have a big change, that means that variable has a big impact, and also the steepness. If this the slope is very steep, that means that variable has a lot of impact on your project. Okay, so that's another way to make it, but here you have to dimensionalize that change in CapEx. Okay, you have to say here a bit more careful to plot. And of course, these curves, if you do it for 20-something%, be aware they might not be straight line. Okay, they can be curved. Actually, you can have something like that. So you have to use some sort of a curve. Okay, it cannot be a straight line. Okay, that's all I had to say, and I took already, just to tell you that, I took 20 minutes, not very efficient. But with that, I think you have everything you need for the exercise, okay, to solve exercise 2. Next class, next week, we are going to talk about network, and we are going to talk about a bit about exercise 1, okay? So have a nice weekend. See you next week.